In this lesson, we're going to learn how to simplify radical expressions even more by being able to add and subtract as well as just reduce them. And what I mean by that basically is this. The last lesson we learned, hopefully you remember that we can reduce things like the square root of 20 by factoring or breaking up 20 into its factors and finding ones that are perfect squares, right? 4 times 5 is 20, but I know what the square root of 4 is because it's a perfect square. Square root of 4 is 2, and I get 2 square roots of 5. So that was reducing radical expressions by square rooting any factors that are perfect squares. But now we're going to also learn how to add them. And before we do that, let's just make sure we kind of remember when we add like terms or like things, how we write it. For instance, if I was to give you, let's just use a variable for a moment, x plus x plus x plus x plus x equals, how do we write that in a simplified form, right? We have 1, 2, 3, 4, 5 x's. We write it as a coefficient like 5x's or 5 times x, because that's what multiplication is. It's multiple addition, 5x. The same thing can be true with roots. In other words, if I give you the square root of 5 and I add that to the square root of 5 and I add that to the square root of 5, I can simplify that because I have how many square roots of 5? I have 1, 2, 3 square roots of 5. So I can write that as 3 square roots of 5. So if I give you 7 square roots of 13 and I add it to 9 square roots of 13, as long as they're the same square roots, I have 7 of them here, I have 9 of them here, both are the square root of 13, I have a total of 16 square roots of 13. That's all this is simply, just being able to add like square roots. And subtraction's the same way, right? If I have 18 square roots of 5 and I minus 10 square roots of 5, if I have 18 and I minus 10 of them, I have 8 square roots of 5 left. Notice how I don't subtract out the square root of 5, or I add the square roots of 13 to get double them. I mean, I'm adding 7 to 9 to get 16, or 18 minus 10 to get 8. Now, they might actually have you do a combination of reducing as well as adding like terms. So you might be given something like this. 2 square roots of 20 plus 5 square roots of, give me just a second to think here, 45. Okay, now initially those don't look like those can combine. These are not the same square roots. And by the way, you cannot do that. You can't combine non-like square roots. The square root of 3 plus the square root of 7, you can't combine those. You actually leave them like that. You just can't combine them. So if you don't see the exact same square root, you initially should say, well, those don't combine. I'm just going to leave it like it is. But remember, we might be able to reduce the root itself, thinking of that 20 as the square root of not 20, but 4 times 5, right? Thinking of the square root of 45 as not 45, but the square root of 9 times 5. Now I notice that I can square root the 4 in that first radical, and I can square root the 9 in the second radical, which gives me a 2 times a 2. Square root of 4 is 2. Don't forget that we're actually square rooting the 4, leaving a square root of 5, plus 5 times 3, because the square root of 9 is 3, and then I leave that square root of 5. And then 2 times 2 is 4, so I'm following order of operations, multiplication before addition, plus 5 times 3 is 15, square roots of 5. Now they do have the same square roots. I have 4 square roots of 5 plus 15 more square roots of 5 for a total of 19 square roots of 5. So this expression reduces to 19 square roots of 5. And that's because I could reduce both of those square roots individually. and ended up with just a square root of 5 in both those terms with a constant out front that I added together because it was addition. Now remember, sometimes you will get expressions that don't reduce or don't reduce as much as we would like. So for instance, let's do something like 3 square roots of 27 minus, I don't care, 5 square roots of 50 plus 7 square roots of, let me think here, 48. Looks good. All right. So again, initially we look at those and we say, hey, those do not combine. We can't combine those. But let's start to reduce. Let's reduce this 27, or realize that 27 is a 9 times a 3. Let's break up the 50 into a 25 times a 2. And let's break up the 48 into a 16 times a 3. You might even have broken it down further, like a 4 times a 4 times a 3. And then you get a 4 squared, where the square root and the square cancel from a previous lesson. But here, I'm going to get 3. And again, I just know I'm going to take the square root of 9, which leaves me a 3 outside. I can't square root that 3 because it's by itself, or it doesn't have a pair that's being multiplied with it. 5 times square root of 25 is 5. Square root of 2 will stay as the square root of 2, plus 7 times square root of 16 is 4. Then I'm leave with the square root of 3, right? Just kind of follow down this path. 3 times 3 is 9 square roots of 3, minus 5 times 5 is 25 square roots of 2. 7 times 4 is 28 square roots of 3. And now I can add these two, because I can rearrange using the commutative and associative property, but this one I can't add with them. This is a square root of 2, it's not a square root of 3. So what I'll do is I'll add the 9 square roots of 3 to the 28 square roots of 3 to get 37 square roots of 3, and then I'll minus off 25 square roots of 2. But that's actually my final answer. I can't simplify that anymore. So this should allow you to do today's homework. If you have any questions, please bring them to class.